Today we're going to be talking about factoring polynomials. Our essential question is, how do I factor polynomials? So a polynomial is an expression containing one or more algebraic terms. So we have a few examples. 3x, that's one algebraic term, that's a polynomial. X minus 2, 3x squared minus 4x plus 10y minus 0.5. So that's an expression. All of those are expressions containing one or more algebraic terms. The greatest common factor, remember you can also write that GCF for short, that's the greatest factor that divides two numbers. So today, one of the things we're going to be doing is factoring the GCF out of polynomials. So that's the first step. When you're factoring, the first thing you want to do is you want to look for any GCF that you can pull out of that polynomial first. So if I gave you 3x squared minus 12x plus 6, and I said factor out the GCF, or even if you were to just start here, the first step that you do is you take out a GCF. The GCF here is 3, so we're going to take a GCF out of 3, and what are we left with when we divide each term by 3? X squared minus 4x plus 2, right? So we have to remember that if we were to distribute this back, we need to get this answer. So 3 times x squared is 3x squared, 3 times negative 4x is negative 12x, and 3 times 2 is 6. So we get that answer, we get the top, our original function, our original polynomial, okay? So here, what's the GCF here? So here it's 5 and x. So notice each term has an x, so we can factor out a GCF of 5x. So if we take out 5x, what's left? If we divide the first term by 5x, we get just x left. And if we divide the second term by x, we get plus 4. And that's it. That's your answer. Okay, number 3. So let's think with the GCF. The GCF is going to be 5y squared, right? Every single term, this term, and this term, has a y that's greater than or equal to y squared. So we can take out 5y squared. So divide each term by 5y squared, we get 15y cubed plus 2y plus 1. Remember, when we're dividing out, so like 75, right, the 75, and we divided this by 5, we got 15, right? But remember when we divide out exponents, like when we do y to the 5th, and we're taking out a y squared. We're subtracting, so it's 5 minus 2. So 5 minus 2 is 3. So that's how we got that y cubed. And when we multiply it back, like if we were to multiply it back here, y squared times y cubed is y to the 5th. You add those. And then also in the same way, y squared times y, remember this is to the first power, if I can write a 1 there, 1. That first power, you're going to add those as well. So it would be 10y cubed, which is how we got that. Okay? All right. And this one, what's the GCF? The GCF is 5. So if we take out a 5, we're left with y squared minus 16. All right. Now, if I said factor out the GCF, we'd factor out the GCF of each of these terms. But do you notice what y squared minus 16 is? This is something called the difference of two squares. And I know that you guys have seen this before, but let's talk about what that is. What's the difference of two squares? So the difference of two squares are two terms that are squares and separated by a subtraction sign, like this. A squared minus b squared. So this can be factored into a plus b times a minus b. Okay, so if we have a squared minus b squared, it could be factored into a plus b and a minus b. So let's look at the example. So look at this again, right? We took out a 5 at the very beginning. We said, oh, okay, this can be divided by 5. So we took out a 5, our GCF was 5, and we're left with y squared minus 16, right? We have to notice that what we're left with on the inside is called difference of squares, difference of two squares. So let's take a look on the next slide. I think I tried to do it down there. Yeah, so let's take a look at our last example. So number 4 in our last example, it was 5y squared minus 80. We said the GCF was 5, and we took out y squared minus 16, right? Now, this is a difference of 2 squares. How can we make that 16 into a squared term? So y squared, right, minus 4 squared. 4 squared gets us 16, right? And 16 is a perfect square. So our perfect square, when we break that down, it's 4 times 4, right? And that's 16. So that's how I got this piece right here. So now we have our a and our b. Remember I said that difference of 2 squares can be written like this, a squared minus b squared? So what's our a going to be? Well, our a, isn't that y here? A is y. And our b term is 4. So a is y and b is 4. So when we do our difference of 2 squares, we're going to do, remember it can be written like this, a plus b and a minus b. So we can write it like this, y plus 4, right? We're doing a plus b, which is y plus 4, and then y minus 4. And that's it. That's how we'd write that difference of 2 squares. So at the very end, remember we had a 5 taken out already. We already had that 5, that GCF of 5. So 5 times y plus 4 times y minus 4. That's our final answer. So let's factor this piece. So x squared minus 25. The first thing we look for is a GCF. Does this have a GCF? No. There's x squared and 25 have nothing in common. We can't take anything out. So the next thing we look at is we say, okay, well there's 2 terms. Whenever there's 2 terms, the first thing we look for is GCF, and the second thing we look for is difference of squares. So we notice that is a difference of 2 squares. It has a subtraction sign, and x squared and 25 are perfect squares. So x squared minus 25, oops, I went too little too fast. So x squared minus 5 squared. We can break that 25 into 5 squared, right? That's a perfect square. So that means we can write it x plus 5, x minus 5. That's it. We're done. That's our answer. So let's factor out this. So now the first step is we notice, does this have a GCF? Does this here have a GCF? Remember the last one we looked at did not have a GCF. Does this one? It does. We can take out a 3. So let's do that first. Oh, I just told you the first step. Okay, I didn't realize. So you guys try this one. Factor out a 3 first and then see what you get. Okay, so try this one. And then I guess I'm trying this next one with you. So let's factor this. Okay, so I write all these out ahead of time and then I totally forget what I'm doing once I get in here. So sorry, try the factor out the last example and we'll factor this one together. So does this have a GCF? Also, look, this has a y to the 4, an x to the 4th, right? So this is to the 4th power. So notice that, and we'll talk about that in a little. But does this have a GCF? It does. What can we take out of 16 and 36? A 4. So can't we write this? If we take out a 4, we can write it as 4 times 4x to the 4th minus 9. So that's the first step. Now, we look at the inside of the parentheses. Look here. Look here. See how it's 4x squared, 4x to the 4th minus 9? Is 4x to the 4th a perfect square? It is. We can actually write that, so that's a difference of 2 squared. We can write that as 2x squared squared, right? So can't we write, so if I did 2x squared and I multiplied that twice times 2x squared, 2 times 2 is 4, and x squared times x squared is x to the 4th. Remember, we always add these 2 powers. So that's going to equal 2 times 2 is 4, and x squared times x squared is x to the 4th. And that's what we had here, right? So is when we have a 4x to the 4th, and we have an x to the 4th, we can write that. That is a perfect square. So we can write that as 2x squared. And then what's 9? 3 times 3, right? So minus 3 squared. So our a in this case is 2x squared, and our b is 3. So remember, then we can go into 2x, it should be 2x squared plus 3. 2x squared plus 3, and 2x squared minus 3, because this is our a and this is our b. And remember, we can go right into a plus b and a minus b. Okay? All right. Don't forget, we need to write that 4, right? So see that purple line that's drawn? We need to put a 4 in front, because that was at the beginning. We had a GCF of 4, so we cannot forget that 4. We can't forget to add that back in at the very end. Okay? That's probably a really common question. So be careful there, because it's really easy to forget about that 4, because you've been doing so many other things while you're working out the difference of two squares. So be careful. Okay, factor. 12x squared minus 27. So there's a GCF. What is the GCF? This one might be a little harder to see, but it's a 3. So if we take out a 3, we're left with 4x squared minus 9. Is the middle part a difference of two squares? Yes. How can we write 4x squared as a difference of as a perfect square? So we could say, okay, 4x squared is a perfect square. How can we break that down? 2x squared. 2x times 2x is 4x squared. Minus 3 squared. We have our a term and we have our b term, so we're going to do a plus b and a minus b. So 2x plus 3 and 2x minus 3. And then don't forget about your 3 for the GCF that we took it at the beginning, and that's it. Okay. What about if we have two terms, and there's a minus sign in between, then we can do difference of two squares if both of the terms are squared. But what if we want to factor quadratics when a is 1? So what if we have 3 terms? With 3 terms, it can never be a difference of two squares, because it has to have 2 different terms to be a difference of 2 squares, right? So in this case, what if we had x squared minus 3x minus 4? The first step we're going to do is put our numbers, our coefficients, into an x. So you might have seen this before. This is x factoring. So it multiplies to a times c, and it adds to b. So what is a, b, and c here? Remember, when we pull out a, here a is 1, this 1, right? B is the number in front of the x, this is negative 3, and c is negative 4, right? So we have a is 1, b is negative 3, and c is 4. Negative 4. So I'm going to write that out actually. A is 1, b is negative 3, and c is negative 4. So now we can plug that in. So see here how it has, so look back over here. See how it has a times c? We have a is 1 and c is negative 4. So we're going to multiply 1 times negative 4. That multiplies to that. It has to add to our b term here. And our b term here is negative 3. So we're going to put a negative 3 in on the bottom. So this is telling us, and also let's multiply. What's 1 times negative 4? That's just negative 4. So let's multiply that and just put it negative 4. So we have to find a number that multiplies to negative 4 and adds to negative 3. All right, so let's think about the factors of negative 4. Okay, we have to figure out what numbers multiply to negative 4 and add to negative 3. So we have to find the factors of negative 4. So negative 4 times 1, if we think about the factors of negative 4, just think of the factors of positive 4. So the factors of positive 4, like 2 times 2, 1 times 4, right? And then just add negatives to them and see what happens. So here we know it's negative 1 times 4. Oh, sorry, negative 4 times 1. And we have to make sure, does that multiply to a negative 4? Yeah. Does that add to a negative 3? Well, negative 4 plus 1 is negative 3. So yes, it does. So we can jump straight in now to x minus 4, x plus 1, whatever this is, x minus 4, and then x plus 1. And that's it. That's our answer. So factor x squared minus 14x plus 45. So remember, up here it tells us multiplies a times c, adds to b. So let's pick out our a, b, and c. A is 1. And remember, we cannot do it exactly this way if a is anything different than 1. So we're not going to look at that yet. But make sure your a is actually 1. Okay? So those are our a, b, and c terms. Okay? So write that down. A is 1, b is 14, and c is 45. Now, 1 times 45. Remember, a times c. Our a is 1, our c is 45. And our b term, our b right here, is negative 14, right? So that piece, negative 14, we're going to put on the bottom right here. 1 times 45 is 45, so I'm going to replace that with 45. So we need to find what multiplies to 45 and adds to negative 14. So think about what the factors are of 45. 1 times 45, 3 times 15, 9 times 5. So now we know that it has to add up to a negative 14, right? Mess around with these and make them negative and positive and see if, like, make the negative 3 maybe. If we make that a negative 3 and 15, if we do negative 3 plus 15, that does not equal 14, so it can't be that. What about 9 and 5? So if we did 9 times 5, 9 times 5 is 45, and 9 plus 5 is positive 14. But what if we made them both negative? Negative 9 plus negative 5 is negative 14. So that's our two different terms. So we can write it straight away into x minus 9 and x minus 5. Now, our goal, remember, the reason we can go straight into this is because when we multiply back out, do you remember FOIL? So first, outer, inner, last. So we're going to multiply, like, x times x is x squared. X times negative 5 is negative 5x. Negative 9 times x is negative 9x. You see what I'm doing? And then negative 9 times negative 5 is positive 45. And then if we add the two terms in the middle, it's x squared. This piece is minus 14x plus 45. Isn't that what we got up here? So it does multiply back out. Okay, it does multiply back out. So we want to, our goal here is to, when it does multiply back out, we're getting our original function. But we can actually just, when a is 1, we can jump straight into here. All right, so factor. I want you guys to try this one as well, and then raise your hand when you're done.